Hello class, welcome to this video on Geometry Cycle 1 Assessment Review. So looking at the first question, first standard is to be able to prove relationships and theorems about lines and angles and to solve mathematical and real world problems. Alright, so first it says 7th Avenue runs perpendicular to the 1st and 2nd streets, which are parallel. However, Maple Avenue makes a 115 degree angle with 2nd Street. What is the measure of angle 1? We haven't actually gone to this lesson yet. We're actually headed to this lesson in 3.7, but I did want you to understand how to do problems like this so that whenever we get to lesson 3.7 / 3.9, you're able to, do these types of problems. Okay, so since we're running a little behind, we haven't gotten to that lesson yet. But here it says that these are parallel. So these lines are parallel. So that means, and then it says that 7th Avenue runs perpendicular. Perpendicular means that it crosses at a 90 degree angle. So you can see that here, there's a 90 degree angle there, 90 degree angle there. So they've already given us that information. Now it says that this is 115 degrees, so they want angle 1. So I'm going to kind of review these concepts first. So here's how it looks like if you have two parallel lines cut by another line, and here are the angles. There are a total of 8 angles that can be formed as a result. Now this is what you need to know, is that when you have two parallel lines and you have 8 angles formed when they're cut by a line, what you have to know is that there are only two types of angles that you can have here. You can have angles that are congruent or angles that are supplementary. All right, so for example, I'm going to make up a number here. Let's say this is 20 degrees or 120 degrees. Well, notice that 1 and 2 are a linear pair, so that means this has to be 60. Okay, and if this is angle 1, if angle 1 is 120, angle 4 must be 120 because they're vertical. And same thing with 2 and 3, those are vertical angles. Okay, now when it comes to 5, 6, 7, and 8, if you know that angle 1 is 120, then that means angle 5 must also be 120. And that is because angle 1 and 5 are the same type of angle. Notice that they're the same type of angle. And same thing for angle 2 and 6. Notice that they're the same type of angle. They're both the acute angle, right? That kind of angle. So they're the same type of angle. So angle 6 is also 60 degrees. Okay, so we call these angles corresponding angles, okay, where they correspond to the same type of angle, okay? And we'll get more into detail on this, in the lesson. And then now if this is 120, then this is automatically 120. And if this is 60, then this is 60. So really the only extra step here that we haven't really talked about is the fact that 1 is the same as 5. And then once you know that, you can figure out the rest of them. Okay, so in this example, we can see that this is 115. Well, if that's 115, well, then that means this has to be 115 right here, right? Based on what I said, because those are corresponding angles. And then notice that these two form a linear pair. So those two have to add up to 180. So we can figure out what angle 1 is by subtracting it from 180. Okay. All right, so then angle 1 has to be 65 degrees. Now this is only true if the lines are parallel, which they told us that they are parallel, okay, here. All right, so there's angle 1. Number 2, from the diagram, which of the following is a true congruency statement? All right, so now we got 3 parallel lines, so 3 lines that are parallel, cut by a transversal, cut by a line that goes through them. So in this case, what we can say, so if we go back to our picture, right, here, we can see that the angles that are outside like this, that switch sides, are the same. Same thing for the 60. We can see that angles that are on the inside but switch sides are the same. And we can see angles that are corresponding, right? Like for example, this one and this one, right? Where they're the same type of angle are the same. Okay, so if we have a situation where we have, for example, 3 lines cut by a transversal, Well, then I would expect for this angle here and this angle to be the same. I would also expect, for example, this angle and this angle to be the same, right? Things like that. I would also expect this angle and this angle to be the same because they switch sides. Notice how the 120 and 120, right? So those are the types of angles I would expect to be the same. So if I look here, well, they're saying, okay, 1 and 4 are congruent. Is that true? No, because those form a linear pair. They have to add up to 180. So that can't be true, right? They add up to 180. So they're a linear pair. They add to 180. 5 and 12. 5 and 12, are those the same? Well, they're not based on my picture, right? So based on my picture, it would be 12 and 6 that would be the same. Right? If I were to compare that picture with this picture, it would be these two that would be the same, right? So it can't be 5 and 12, so that's not right. Another way of looking at it is, notice that 6 and 12 are both acute angles. They're small, but 5 is obtuse. So now look at 8 and 1. 8 is an acute angle, it's tiny. 1 is an obtuse angle, it's big. So they can't be the same, right? There's no way. So that crosses out that one. Now angle 1 is an obtuse angle, and angle 11 is also obtuse. So we would expect that they're the same. Also, we've already mentioned that the opposite angles are the same, right? So that makes sense. So that would be, these are called alternate exterior angles. Alternate exterior angles. Okay, so these are called alternate exterior angles. Okay, and we'll go over to that in detail when we do the lesson. All right, so so it says 3.1, determine the weighted average of 2 or more points on a line. Now this is old stuff. The weighted average of 2 or more points is given by the formula W1 x1 plus W2 x2 plus dot 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 over W1 plus W2 plus dot dot dot. You basically keep going until you get all the points that you want. W1, W2, W3, whatever, depending on how many points you have. That's the weighted average formula. Okay, so if we use that here, it says point W weighs twice as much as point X. Okay, so let's label these. We have 4 points here. So we have W1, W2, W3, W4, right? So let's call this, I'm going to call this point 1. So I'm going to call this point 1, point 2, point 3, and point 4. So in this case, we have x1 is -7 because W is located there, right? What's the x coordinate for point 2? Well, the x coordinate for point 2 is -4. The x coordinate for point 3 is at 0. The x coordinate for point 4 is at 5. So we got ourselves our x coordinates. Remember that we need that for this formula, right? x1, x2. The next thing we need are the weights. So it says here W weighs twice as much as X. Y is 3 times as much as X. So let's go ahead and call let's make up a value for the weight of X. So let's call it W2 is equal to 1. Now if the weight of X is 1, I just made that up, then that means that the weight of W is twice as much. So it has to be a weight of 2, right? It's 2 times 1. Now, if X is a weight of 1, then Y is 3 times that. So it has to be 3, right? 3 times 1. Now it says Z is half as much as W. Okay, so Z here weighs half as much as W. Well, what's W? What's point W? Well, W is 2, right? So then half of 2 is 1, right? So therefore, Z has a weight of 1. All right, hopefully that makes sense. You're going to need to show some work on a separate sheet of paper just because there's not enough room for this, unfortunately. So I'm going to do it over here. I'm going to take this information and I'm going to copy and paste it here. All right, so now I'm going to use the equation. This time I'm going to continue this till I get to x4, right? All right, this is a formula you have to memorize. So if they ask you a question like this, you're going to need to know this. All right, these are the part of the standards. All right, so we got W1. This should say a 1, not a 2. All right, so W1 equals 2. All right, so W1 is 2. X1 is negative 7. So I'm just plugging these in. I'm plugging this in there and there. All right. W2 is 1. X2 is negative 4. W3 is 3. X3 is 0. W4 is 1. And X4 is 5. Over W1 plus W2 plus W3 plus W4. Again, we're plugging those in, right? That's how I'm getting those values. All right, we're doing the math here. So we got negative 14 minus 4. 1 times negative 4. 3 times 0 is 0. 1 times 5 is 5. Then we got to add this up. 2 plus 1 plus 3 plus 1. That's 7. So we got negative 14 minus 4 plus 5. That's negative 18. So I got negative 13 over 7. And that's my weighted average. So we got negative 13 over 7. That's going to be some kind of decimal. All right, that takes care of number 3. That's my weighted average. So I'm going to say the weighted average is x equal to negative 13 over 7. Again, you're going to need to show the work for this. Okay. All right, number 4. Some paper weights are placed on various points on a ruler. The paper weights are A, B, and C weigh 2 pounds, 5 pounds, and 3 pounds. So we're going to call that point 1, points 2, points 3. So we got x1 is 0.1. x2 is between points 2 and points 3. So it's between points 2, 5, right? Halfway between point 2 and point 3. And then point 3 is at an x coordinate of 0.8. We need to write down the weights though. So it says that the paper weights are, the weights at A is 2 pounds, B is 5 pounds, and 3 is 3 pounds. Okay. It says, where should a fulcrum be placed below the ruler in order for it to be balanced? So in other words, they're asking for the weighted average. Where would I balance this? Okay. All right, so let's do that. Again, we're gonna do the same thing. Do it over here. All right, and we're gonna use the weighted average formula. Okay, so again, x equals, we got x1 or w1 x1 plus w2 x2, right? Plus w3 x3 over w1 plus w2 plus w3. So you're going to plug in those numbers. w1 times x1 plus w2 times x2 plus w3 times x3 over w1 plus w2 plus w3. Do the math here. All right, so we got 1.25, 2.4, that's 3.65. So we got 3.85 divided by 10. So we got 0.385. I guess, I don't know if that would be centimeters, but I'll just put that 0.385 for the weighted average. Okay, that takes care of problem number 4. So now 0.385 should be right around there, right? So the weighted average would be around there. Okay. All right, so next standard is use coordinate geometry to solve mathematical and real-world geometric problems. All right, so it says point Z is the midpoint of XY. with endpoints -1, 4 and 3, 6. Find the coordinates of point Z. So Z is the midpoint. We need to find the midpoint. Okay, so the formula for the midpoint is x1 plus x2 over 2, y1 plus y2 over 2. So let's call this x1, y1. This is x2, y2. We simply have to plug it in. So we got x1 plus x2 over 2. We have y1 plus y2 over 2. So we get -1 plus 3, that's 2. 4 plus 6, that's 10. So we get 1, 5. That's it. 2 divided by 2, 10 divided by 2. Done. All right, number 6, it says that point B is the midpoint. So this time they're giving you the midpoint. That says point D has the coordinates 1, 7. What are the coordinates of point C? Okay, so they're giving you the midpoint, but we don't know what point C is. We know what the midpoint is, and we know that D is 1, 7, but we are trying to look for the end point. So this is the reverse problem of number 5. Okay, so number 5 is they give you this and one of the points, and you have to figure out the other coordinate. Okay, so how do we do that? Well, first off, we know what the midpoint formula is, right? We're going to call this, we know that to find the midpoint, I would need to do x1 plus x2 divided by 2, right? And then I would need to do y1 plus y2 divided by 2. That's exactly what this formula says, right? To do x1 plus x2, y1 plus y2. All right, but this time we're going to call those x and y. So we know that this is x and this is y. This is x1 and this is y1. Now, this is going to be x2, y2. We actually don't know what that is. So the midpoint is given by xy. The coordinates are given by x1, y1, x2, y2. But we don't know x2, y2. So we're going to plug in what we know. We know that x is -3. We know that x1 is 1, but we do not know x2. For y, we do know that y is 1. We do know that y1 is 7, but we do not know y2. So we need to solve for x2 and y2 here. In order to do so, we need to multiply both sides by this 2 in order to get rid of it. So that's exactly what I'm going to do. I'll do this here as well. So again, these 2's cancel. It's very nice. Now 2 times -3 is -6. 2 times 1 is 2. And now we're going to solve these two equations for x2 and y2. So here we have to subtract 1. So that's going to be -7. Here we need to subtract 7. That's going to give us -5. So now we know what the coordinates are. The coordinates have to be -7 and -5. Therefore, the answer is B. All right. Number 7 is another type of example with coordinates and lines. It says in the diagram below, AC has the following endpoints: -5, 2, and C is 4, -10. Now, if B is a point on AC and AB to BC is a 1:2 ratio, what are the coordinates of B? Okay, so this is a partitioning problem. They may ask you this type of problem in the cycle. In fact, there's probably a good chance, all right? Because we had talked about this in an early chapter. So when you see a partition problem where they give you a ratio, right? Then you need to use the section formula. Okay, so the section formula, here's the section formula. It's x equals nx1 plus mx2 over m plus n. We haven't seen this formula in a while, but we have to remember how to use it, okay? And again, I'm writing pretty big, so you may, if you need space, of course, do it on a sheet of paper. But here I have the luxury of being able to just write wherever. But again, just don't necessarily do exactly what I do. Just write down the stuff here on a sheet of paper. So we have x equals y equals. Now we need to find the coordinates. Well, we know this is x1, y1. This is x2, y2. Now, m and n, remember, comes from here. So that's m, that's n. M is 1 and n is 2. So all you got to do is plug that in here. So we got x equals n is 2, x1 is -5. Again, that's coming from the graph there. M is 1, x2 is 4 over, and then add the m and the n together. So 1 plus 2. Let's do the same for y. Y equals, we got n is 2, x or y1 is 2, the m is 1, y2 is -10 over 1 plus 2. Okay, so that's how you set it up. Now we just got to do the math, and to get the solution. So we got 2 times -5, 1 times 4, 1 plus 3. 2 times 2, 1 times -10, 1 plus 2. All right, so we get -6 over 3, which is -2. Here we also get -6 over 3, which is another -2. So we can see that our coordinate has to be -2, -2. We see that there. -2, -2. This is where my coordinate lies. And what this point will do is this point will split it in a 1:2 ratio. All right, so there you go, -2, -2. All right, so my next learning target is use coordinate geometry to solve math and real-world problems involving perimeter or area. This is what we did in Chapter 2, Lesson 3, when we did area and perimeter. So solve for the perimeter of a trapezoid given below. Round your answer to the nearest hundreds. Okay, so we got ourselves a trapezoid. That's a 4-sided shape. We just want to find the perimeter. The perimeter is when we add up all the sides, okay? So we got to add the sides. All right, so we know that this side, we can count this side, right? It's 1, 2, 3, 4. Remember that you got to be careful with the scale, because this is 3, this is 4, this is 5 here, that's 6, and then that's 7. Okay, so really we have 1, 2, 3, 4 jumps. You can also just subtract 7 minus 3, okay? So you can do that, and that's probably going to be easier. All right, so this distance is 7 minus 3, which is 4. All right, now this distance, again, is another 7 minus 3. You can see that there. Okay, so we got 4 and 4 for those. And I'm going to just do 4 here. And I'm going to do 4 here. All right, so we got those two sides. Now for the other two sides, we need to use the distance formula, or we just need to count up and over, okay? So here I'm going to go over and down, okay? So how much do I need to go over? Well, I need to go over 7 spaces because I'm going from 0 to 7. You see that? So it's 7 minus 0, or 7. So again, we get that by doing 7 minus 0, which is 7. And then for the next one, we're going from, again, 0 to 7. So it's going to be another 7 minus 0, which is 7. All right, I'm going to call this x. So remember, this is a right triangle, so I can use Pythagorean theorem here, right? Which is a squared plus b squared equals c squared. So I have 7 squared plus 7 squared equals x squared. And then I'm going to need to take the square root, okay, to get x. So 7 times 7 is 49. 49 plus 49 is 98. So this is the square root of 98. That's going to be some kind of decimal. We'll get that later. All right, the next one, we have this line here, which it goes down from 3 to 0. So that means it's 3 minus 0, which is 3. And then this one here is, again, from 3 to 0. So 3 minus 0 is 3. It's another Pythagorean theorem. So we have, I'm going to call this y. So we have y equals square root of 3 squared plus 3 squared. I'm going straight to the punchline. Just take the square root, add those numbers up. So we got 3 times 3 is 9. 9 plus 9 is 18. So this is square root of 18. Now we have to find the perimeter. So add up all the sides, right? So we have 7 plus 7, or 7 plus 4, plus square root, or no, I'm sorry, how did I get 7? 4 plus 4, sorry. 4 plus 4 plus square root of 98 plus the blue square root of 18. All right, and we'll just do this on the calculator. Again, get a decimal off of it. So let me do that here. I'm going to do this on the calculator, see what I get. So 4 plus square root of 98. You can all do this on Desmos and it'll be easier. And you get about 22.14. So the answer is A. All right. It takes care of that. So now number 9, find the area of the figure whose vertices are given by the following coordinates. So here is probably a good idea to draw that. That's K, which is at -1, 1. We have L, 1, 2, 3, 1, 2, 3, 4. So we have 3, 4, that's L. M here is 6, 0. And N is 2, -3. All right, so this is the shape that we got. Okay, so now this is going to involve a concept that we haven't reviewed yet, but it is a concept that you should be familiar with, ideally from Algebra 1. However, I realized that a lot of you guys don't remember a lot of the stuff in Algebra 1, so I want to review that. And we'll review this when we do later on in the chapter, but we haven't gone to it yet. So first off, we have to know that these are right angles. How do we know that this, for example, is a right angle? Well, the way you would know is you would basically find the slope. All right, so let's just count these because we got to count these anyways. So let's do a right triangle like there and there. So if we count this down, that's going to be 4. And count this over, 1, 2, that's going to be 3. All right, so we know that the slope, remember slope is rise over run. So right now, this is going down 4. That means it's -4, okay? So the slope of, so let's write this down. So slope is rise over run. Rise has to do with going up and down. Run has to go left to right. So the slope of that line is it's going down 4, so down is negative, and it's going to the right 3. So the slope is -4 over 3. Okay. Now I'm going to do the slope of this line by doing another right triangle, rise over run. So how much does it go over? Well, it goes over 4 here to the right, and it goes up 1, 2, 3. So the slope for the blue one is rise over run, which is it rises 3 and it's going up, so it's positive, and it's going to the right, so it's +4 for the run. Now I want you to notice these two slopes. These two slopes are eerily similar in some way. Notice that one slope is the flip of the other. So let's write those out. If I flip this, I get the red slope. Okay, so they're flipped. So notice that if they're flipped and their signs are opposite, right? This one's positive, that one is negative. If the signs are opposite and they're flipped, we call those negative reciprocals. If they're opposite or negative reciprocals, for the slopes, that indicates that we have a right angle. Okay? Another way to think about it is that if I multiply the two slopes, I would get multiply straight across negative 12, 4 times 3. 3 times 4 is 12. And I get negative 1 because 12 divided by 12 is 1, but it's negative. If I multiply the slopes and I get negative 1, that indicates that it's a right angle. It's perpendicular, okay? So that's how we know. Two ways to figure it out. Look at the slopes to see if they're flipped negatives, or look to see by multiplying the slopes to see if you get negative 1. Since this is the case, that means this has to be a right angle, which means that we're looking at probably some kind of square or something like that, right? If you were to do this for all of these, you would find that it would be a square. We try it for all of these, okay? And we'll do that real quick. So if I go here, 1, 2, 3, that's going to be a 4. All right, notice that that's the same as the blue. Same thing here, it goes over 3 and then down 4. So notice that these are all like opposite reciprocals. So these are all right angles, okay? So we're looking at a square. All right, so let's go ahead and find the length. So remember, to find out the length, we have to do the Pythagorean sum, right? The Pythagorean formula. So to find x, we have to do a squared plus b squared equals c squared. Or we could just do 3 squared plus 4 squared with the square root over it. But notice that's the same thing as y, right? Because x and y are the same numbers, 3, 4, 3, 4. But I'll just show the work anyways. All right, so this is going to give you 5. All right, so we got 5 everywhere. 5, 5, 5, 5. So remember, we want to find the area. So what's the area of a rectangle? Well, the area of a rectangle is base times height. So we'll call this the base, and we'll call x the height, or the red the height. So we got 5 times 5, right? Which is 25. So 25 units squared. All right, so fairly involved. You had to know that it's a square, and therefore then you can find the distance and then multiply them. All right, so the next standard, solve mathematical and real-world problems involving surface area. All right, so number 10, it says a castle model has a cone-shaped roof. The cone side is 45 centimeters long, and the base radius is 27 centimeters. Suppose wallpaper is needed to be glued onto the roof. How many centimeters squared of wallpaper is needed? Okay, so since wallpaper is being glued onto the roof, you're covering the surface. We're talking about surface area. How many centimeters squared of wallpaper? This is a surface area problem. All right, so it says the cone side is 45 centimeters long. So let's draw that out. So it's 45 centimeters. And it says that the base radius is 27 centimeters. So that's the radius is 27 centimeters. And we just want to find the surface area. So we need to find the surface area of this cone. So let's go to the formula sheet, on the EOC formula sheet. We have a cone, we're looking for the surface area. So B plus pi RL. Now, if we go back to that question, they're saying you need to glue it onto the roof, right? So since you're gluing it onto the roof, you're only doing this part right here. You're not doing the black part, right? You're not doing that part of the roof, you're doing the red part, right? So we need to find the red surface area, okay? So since we're not doing the base, we do not need the base part of the formula, okay? So we're going to cross that out essentially. We're only looking for the pi RL part, okay? So the formula here is simply going to be pi RL. We won't need the base part. All right, so then in that case, let's just write the formula here. We have pi times the radius was 27 times the 45. All right, and then we got 27 times pi times 45. So we have about 3,817.04. centimeters squared. So approximately. All right, again, you know, draw the cone and all that stuff. So if you need more room, again, do it on a separate sheet of paper. Might be easier for you to do it that way. All right, so, and then just number the problem. All right, so number 11, it says for a project, Mark decides to construct a model of the Pyramid of Menkaure, a square pyramid. The height of this model is 2 feet, and the side of the base measures 3.2 feet. Okay, so so we got a square pyramid. Something that kind of looks like that, right? Square pyramid. The height of the model is 2 feet. So that's the capital height. The side of the base measures 3.2 feet. Again, this is not drawn to scale. If that's 3.2 feet, then that means this is 3.2 feet here as well. Okay, everywhere. So these are all the same. Since it's a square pyramid, he needs to paint the model. Suppose the average cost of painting the model is $1.50 per square foot. How much will it cost to paint his pyramid model? Okay, so he has a model. He's going to paint all around it. Okay, so if we're assuming he's painting the entire model, that includes the base as well. So that means we'll be doing the entire top part, and then since it's a model, he'll be able to paint everything, right, including the base. So I'm going to go ahead and shade the base, and I'm going to draw the base. It's just a square, 3.2 all the way around. Now we also in order to calculate this, we would need the slant height of the pyramid. Okay, the slant height is this distance right here. It's the height at an angle. Okay, so notice that if I were to draw this makes a right triangle. You see that? So let me draw that right triangle like this so you can see it. So then what is this distance right here? Well, this distance has to be half of 3.2. So we're going to do 3.2 divided by 2. And that's 1.6. This has to be 1.6 feet because it's half of this, right? And this is going to be my capital H, which is 2 feet. So in order to get L, we need to use Pythagorean theorem. All right, so 2 squared plus 1.6 squared equals L squared. And then we could just take the square root of both sides, okay? So L equals the square root. That's a cursive L. We got 2 squared is 4, 1.6 squared. All right, let's just figure this out on the calculator. I'm just going to do it on the calculator. Square root of 4 plus 1.6 squared, 2.56. Okay, so 2.56. You could do this on Desmos to make it easier. So 2.56 feet. All right, now we know what that is. All right, we're going to need that later. That's why I'm finding it now. Okay, so now we need the surface area of a pyramid, right? So we need to go to the formula sheet. We got a regular pyramid, so surface area. That's where that L is. You see that L? That's where that L is, which I call the cursive L. All right, so we got B plus 1/2 PL. B plus 1/2 PL. Let me write that formula down. So SA equals B plus 1/2 PL. All right, so the base, the area of this square is base times height, right? So it's 3.2 times 3.2. Okay, so 3.2 times 3.2, that's 10.24. All right, so I'm going to plug that into here. That's my B. Now we need to find the perimeter. So what's the perimeter of this square? Well, just add up all the sides. So in other words, 4 times 3.2. So you got 12.8. So the perimeter is 12.8. So we'll replace that here. Now the L, we found the L here, so I'm going to plug that in. Okay, so then now you just got to do the math. So you got 26.624. All right, feet squared. That's your guy. Now, that's not the final answer because remember, it says suppose the average cost. We want to say how much does it cost to paint this. It says it's $1.50 per square foot. So if it takes $1.50 per square foot, and this is how many square feet we have, well, we have to do $1.50 times that. And that'll tell us how much money we had to spend to paint, okay? So 26.624 times 1.5, you get $39.90, approximately 94 cents to paint the pyramid. Okay, that's pretty expensive. All right, so there you go. That's how much money in paint to paint the pyramid. If you're doing the bottom as well, which we're assuming. Okay, so number 12, construct a copy of a segment of an angle or an angle. So what is the first step when copying an angle? So when you're copying an angle, you remember that the first thing you're going to want to do is draw a ray with a straight edge. Next, you're going to draw an arc through there, which we'll call this B and C, and through here, which I'll call this D. Next, you're going to want to take the compass and measure from there to there, right, with the compass. And you're going to take that reading and you're going to put the compass here, and then you're going to draw an arc with that measurement. X marks the spot, we'll call that E, and we'll call this F. And so now you can draw that with a straight edge. Okay, and that's how you would copy the angles. Those are the steps. All right, so what is the first step when copying an angle? Labeling the vertex point A on the vertex on the original angle, drawing a straight line, and putting a point labeled A on the copy. Okay, we got opening the compass, we got labeling points B and C, and then using a straight edge to measure a random length from point A on the original angle. All right, so the best answer is probably going to be A based on what I was saying for the first step. Okay. All right, number 13, which of the following is a counterexample for this conditional statement? We looked at counterexamples kind of recently, and semi-recently, so let's review that. It was in the beginning of chapter 3, lesson 1. All right, a counterexample makes things false, okay? So it helps us prove things false. All right, so for this conditional, if a figure is a triangle, then its perimeter is an odd number. So we want to prove that the perimeter is not going to be an odd number. So if we prove that the perimeter is even, assuming that it's a triangle, and we prove that it's an even perimeter, then that would go against the statement. That would prove it false, and that would be a counterexample. Okay? All right, so it says here an equilateral triangle has a side length of 7. Equilateral means all of the sides are the same. So all these sides are 7. So let's see if that's true. The perimeter of this triangle is 7 plus 7 plus 7, which is 21. But that's odd, right? So that doesn't prove this wrong. So this cannot be a counterexample. All right, we have to prove it wrong. A rectangle with side lengths of 5 and 7. Now it says a rectangle. Can we use a rectangle as an example when they say that it has to be a triangle? Of course not. So it cannot be a rectangle. So this cannot be a counterexample. Now here they use square. We can't use that either. Has to be a triangle. If it's a triangle, then we have to prove that it's not an odd number, okay? The perimeter. This has to be D, but let's see why D is correct. We got 11, 6, and 9. Well, if I do the perimeter, I get 11 plus 6 plus 9 is 26. That's even. So that goes against that. So therefore, it has to be that, okay? And that would be a counterexample. So a counterexample has to make the first part true, but the conclusion false, okay? That's what makes it a counterexample. All right, so number 14, it says sphere A. This is involving volume. So it says sphere A has a radius of 20 and sphere B has a diameter of 10. How many times larger is the volume of sphere A compared to the volume of sphere B? Okay, so we got a radius of 20, so R equals 20 for sphere A. I'm going to call this radius A. Sphere B has a diameter of 20, or 10. So if the diameter is 10, that means the radius has to be 5, right? Because it has to be half of the diameter. Okay. So how many times larger is the volume of sphere A compared to the volume of sphere B? Well, there's a couple of ways that you can do this. You can calculate the volume and then divide them. But I'm going to show you kind of both ways. Well, let me show you the main way to do this. The main way to do this is you want to see how many times larger. And so what we want to do is we want to take volume A and divide it by volume B. Okay? So for example, if volume A is 100 and volume B is 50, well, 100 divided by 50 is 2. So then A would be 2 times bigger in volume. So we got to divide them. But we're dealing with a sphere. So let's find the volume of a sphere. Let's go to sphere. All right, there it is, volume of a sphere, 4/3 pi r cubed. So let's use that. So we got 4/3 pi r cubed. All right, so let's write that out, 4/3 pi. Now radius A is 20, so I'm going to do 20 cubed. And then radius B is 5, so 4/3 pi times 5 cubed. Notice that 4/3 divided by 4/3 is just 1. Pi divided by pi is just 1, right? So we have 20 divided by 5 is 4. And then we got to raise it to the third power, okay? So we got 20 divided by 5. I'm going to do this, 20 divided by 5 to the third power. We can split the powers like that and just divide them first and then do the power. So 20 divided by 5 is 4. 4 to the third power is 4 times 4 times 4. Well, that's 64. So that's going to be the quickest way to do this type of problem. So the answer is A, 64 times larger. All right, now 15, suppose Ray wants a cup of water. The cup is cylindrical with a radius of 2 inches and a height of 6 inches. Ray fills the cup halfway. What volume of water in cubic inches did she use to fill the cup? All right, so we got a cylindrical cup with a radius of 2. So we got a cylinder with a radius of 2, r equals 2, and then a height of 6 inches. All right, so we got radius is 2. We got the capital height is 6. She fills the cup halfway, so that means she doesn't fill it up all the way, just half. And so we want volume of water. Okay, so volume. So the volume, so if we're filling the cup halfway, right, that means that it's filled to a height of 3, right, instead of 6. So in this case, we're going to use a capital height of 6 divided by 2, which is 3. Because all we care about is the water level. And the water level is going to be, is what we need. So what's the volume of a cylinder? Let's go to a cylinder here. So let's find the cylinder. All right, there's the volume of a cylinder, VBH. We use capital H there. Remember, we usually use capital H. Now what is B? B for a cylinder, right? So if you got a cylinder, then this is B, right? So B is for a circle. But what's the area of a circle? The area of a circle is pi r squared. So we're going to use b, which is pi r squared, and use that, okay? So we're going to replace this with pi r squared. So let me write down that formula. All right, so we said this is equal to B, capital H, but we said that B is pi r squared because it's for a circle, right? So we have pi r squared H. All right, so we got pi, we had the radius was 2. We have the height is now going to be 3 because we're only filling the cup halfway. All right, so we'll do the math. So we got pi times 2 squared times 3, so that's 37.7. It's going to be inches cubed. That's how much volume of water we have. All right, and that's it. So number 16, what is the final step in constructing the angle bisector? All right, so here are the steps to construct an angle bisector. What you want to do first is you want to do an arc that goes through the angle. I'm going to call those B and C. Next, you're going to use a compass and draw an arc from B somewhere inside this angle. So use a compass to draw that. And then you're going to want to repeat that measurement with the compass from C and draw an arc. This is supposed to be a compass. My drawing of a compass. All right, and then X marks the spot. So then the final step is you connect those, and then that will cut the angle in half. Okay. All right, so the final step. The final step is you're basically going to draw this line to connect, right? Which would be this right here. You connect that. All right, so the final step is to draw AD. That's it. Draw ray AD. All right, number 17. Suppose you want to create a perpendicular bisector for the line segment AB shown. What is your first step? Let me go over all the steps. So the first step is you take a compass and you measure it so it's more than half of the line. So that's more than half because this is like halfway right there. And with that, once you take that measurement, like where it's more than half, you're going to use that compass and use it to draw an arc above and an arc below. Take that same compass measurement from B and you're going to draw an arc below and an arc above with the compass. And now you can connect these. X marks the spot, connect those, and this line is going to cut that in half. Okay, so the first step is to spread out the compass so it's more than half of the line. All right, create an arc. Draw a point C, connect it, create an arc from A. Hold on. All right, so based on what I said, it's going to be create an arc from A with a radius just over half of the line segment. So the answer has to be B based on what we were saying. Okay. All right, so that's number 17. All right, so now we're wrapping this up here. It says identify and accurately interpret if then, if and only if, all and not statements. Converse, inverse, and contrapositive. All right, so it says number 18. If a polygon is a triangle, then the sum of its interior angles is 180. What is the contrapositive of the statement? Okay, remember, this is the conditional, is if then. The converse is when I switch it. The inverse is when I negate both the P and the Q in the original. The contrapositive is when I do both. I switch and negate. Okay? I think they're asking about the contrapositive here. Right here, contrapositive. All right? So we're going to call this P. Then we're going to call the sum of the anterior angles Q. All right, so what we want to do is we want to do, for the contrapositive, we want to do not Q goes to not P. So if not Q, then not P. So if the sum is not 180, then it's not a triangle, okay? So if the sum of the interior angles of a polygon is not 180, that's the not Q. Then, that's the arrow, it's not a triangle. That's the not P. That's what we're looking for. All right, so it's got to be A. All right. Number 19, which statement is the inverse of if x plus 3 equals 7, then x equals 4? So this is P, this is Q. The inverse is not P implies not Q. So not P means that x plus 3 is not 7, right? Not equal to 7. And then not Q is x is not 4. Okay, so if x plus 3 is not 7, then x is not equal to 4. So that's the inverse. Okay. All right. Number 20, given the figure below, which of the compound statements are true? Select all that apply. Okay. So we haven't gone over this. We haven't really gone over these symbols, except for the squiggly. But we haven't really talked too much about this symbol and this symbol. So I'm going to go ahead and go over that real quick. However, I'm not anticipating that they would have this on the cycle. However, just in case, I want to go over it just to make sure that they have it. Okay. So this symbol right here is called a conjunction. This one's called a disjunction. Okay. So this stands for and. Okay, and this symbol stands for or. Okay, so that's what that is. And the squiggly, we've looked at the squiggly. The squiggly means not. Okay, the negation. Okay, so what we're going to do is, it says which of the following compound statements is true. So let's start with P and Q. P is ABC and CBD are complementary. Q is ABC and CBD are vertical. So let's see if that's true. Is P true or false? Okay, so ABC and CBD are complementary. Are those complementary? No, they're supplementary. They add up to 180 degrees, not 90. So this is actually false, right? So this is false. Now Q, it says ABC and CBD are vertical. Is that true here? Are these angles vertical? No, they're not vertical. Vertical is when you have an X, and it would be like the angles opposite, this angle and that angle. That was vertical. Okay. All right, so that's also false. Now let's look at R. AB is congruent to BD. Is that true? Is AB congruent to BD? Well, yes, because they mark it with the symbols here. They're saying that it's congruent. So yes, that's true. Okay, so this is true. So P is true, Q is true, and R is true. Now let's look at this one here, P and Q. So P is false and Q is false. If both of these are false, that means overall it has to be false. Okay? So the way and works is that for and to be true, this is this and symbol, both of them have to be true for the whole thing to be true. If one of them is false or both of them are false, it's going to be false. Okay? All right, so for and, both, so for and is true if both are true. Okay? Otherwise, it's false. So in this case, this is equal to false. So this is false. Now let's look at B. Is that false or true or false? Well, okay, so let me write it out. Not P or not Q. All right, so let's write out. P is false, Q is false. Well, if it's not false, it has to be true. So this is actually equal to true, right? So if it's not false, it's true. So true, or that's not false as well, so it's true. Now let's talk about or. This is and, right? And this is or. This or is false if both are false. So CS kind of opposite. It's only false if both of them are false. If one of them is false or none of them are false, it's true. So in this case, true or true is true. All right, so here this is equal to true. All right, which of the compound statements is true? That one. But let's look at the other ones just to practice. Q and R. Q is false, R is true. False and true. But what we said is it's only true if both of them are true. That's not the case here, so therefore this is false. Okay, both of them have to be true for this to be true. Since one of them is false, it's false. All right, let's look at the next one, the last one. Not Q or not R. Now, Q is false, so it's not false. R is true, so it's not true. Okay, so we got not false. If it's not false, it's true, right? So we got true or, and then not true, it's false, right? So true or false. What we said with or was that it's false if both of them are false. Since both of them aren't false here, then this has to be true. Okay, so we have two statements that are true. So B and D. All right, guys, that's going to do it for the video. I hope you found this useful and informative. And as usual, I'll see you in the next one.